Piece it together insights from 1 year of engagement with electronics and programming for people with intellectual disabilities. The authors were Kirsten Ellis, Lisa Kruesi, Swamy Ananthanarayan, Hashini Senaratne, Lindsay. People with disabilities face many barriers in engaging with technologies that would enable them to create and control hardware and software. The maker movement, computational toolkits, and consumer bots have expanded the cohort of people who are able to engage with these activities, but there has been limited research on their use with people who have intellectual disabilities. In this work, we address the lack of programs for people living with intellectual disabilities through the creation and deployment of a science, technology, engineering, art, and mathematics package comprising of a set of accessible electronic and robotic toolkits. Previous work has shown that individuals with intellectual disabilities are excluded from developing STEAM skills in school due to lack of teaching expertise, financial barriers, time constraints, and inappropriate toolkits and resources. The maker movement has had success with accessible toolkits, enabling students to learn in ways that were previously unavailable. Existing work on introductory toolkits for making have primarily focused on able-bodied populations with good vision and fine motor skills. The maker movement provides clear motivations for including people with disabilities, showing how they can experience the empowering potential of makerspaces. When selecting the STEAM package to deploy, we look for 6 key qualities: diversified repetition, simple interoperability, low manual dexterity thresholds, supporting community and individual activities, building towards personal meaning, language independence through physicality and choice. We included 3 kits in our package. Tape blocks are a chunky electronics toolkit made out of foam blocks, conductive tape, and electronic components. The kits themselves can be used in a variety of ways with varying levels of complexity. The Sphero is a clear, round, programmable robot ball that can be controlled by programming or driving it using an app. It can be used to facilitate activities that require navigating through obstacle courses and can be used creatively. The Bee, Blue, and Rugged bots are a range of robots that can be controlled and programmed directly by pressing buttons on the body of the robot. Unlike Sphero, these bots do not require an external device to program, although they can use one. The research that we undertook was a 12-month engagement at 3 different sites run by a disability support organisation. We involved 11 clients in small groups for between 2 and 4. The disabilities that participants had included intellectual disability, cerebral palsy, autism, and Down syndrome. For data collection, we had regular contact with 5 coaches, undertook contextual inquiry, and also ran reflective interviews with the coaches. One of the sites was chaotic loud, with lots of people moving and engaging, disengaging, and then re-engaging with the activities. While another site was characterised by exceptional focus and quiet dedication to the task. Although the STEAM package was the same at each site, the activities often took on unique qualities to suit the participants at the sites. The physical nature of the toolkits allowed several phenomena to emerge, which would not have been seen if clients were learning in front of a computer terminal. Clients could watch each other at a distance and collaborate on problems together. The physical nature of the activities enabled the participants to integrate the tools into their activities. For example, the participants used the Bee-bots to move the tape blocks around. At one site during the observation sessions, the tape blocks were used to build buildings along a road. The bots were then programmed to navigate the town. The tools enabled the physical mimicking of real-world experience that were of interest to clients. For example, there was a simulated road traffic accident that led to pretend ambulance being called. The language independence of the package meant that it could support community and individual activities. Each of the clients had their own needs for the session and required assistance with different aspects of the activities. Engagement with the kits was persistent over an extended period of time. Clients exhibited different degrees of focus and engagement. We observed multiple instances of failure that the clients were able to overcome by problem solving. We observed several coping mechanisms that clients were able to engage in to maintain or reset their focus. Clients would work intensely on something, then remove themselves for a period, and then re-engage. Humour also played an important role in coping with moments that could otherwise cause frustration. For example, laughing about a pen drawing going off a page. Throughout the program, we observed emerging problem-solving approaches. Clients were able to work through issues, for example, getting the tape locks to light up. There was a procedure that was created by the coaches and participants. This included checking that the tape was stuck down, the connection was secure, and there were no short circuits. When the lights finally worked, they celebrated these moments with clapping and cheering. One of the key takeaways from this work is the importance of allowing clients to spend hundreds of hours working with the toolkits rather than tens of hours, which is more common. There were some pragmatic and methodological challenges that arose during the research. Building a lasting relationship with the disability support organisation and the coaches was important, and training staff so that they were confident improved outcomes. There were pragmatic barriers to the extended deployment. For example, coaches regularly moved around within the disability support organisation. Increased confidence with the tools led to more self-directed work. Coaches and clients started to contribute their own activities to the program using the provided STEAM package and found objects. Coaches shared activities that they and clients had created with other sites, inspiring others to repeat the activities. The STEAM package and toolkits that were used within the research were either developed specifically for our participants or were modified and reframed for the audience. We still need to understand how to keep improving the design of the toolkits and, more generally, how to configure sessions to support creativity without prescribing the form that they should take. Other takeaways include that the sessions themselves can be relatively chaotic and present methodological challenges for observational work. Methodological questions remain as to how we should start to formalise observations and assessments of these interventions. This research demonstrates the capacity of people with intellectual disabilities to build skills, increase independence, and drive personally meaningful electronics and computational projects given adequate time.